Hey guys, we're just going to go through 26E.1 question 4 part C. So we've got a normally distributed set of data, mean of 23, variance of 5 squared, or a standard deviation of 5. You know I'm going to ask you to at least draw a little sketch and show you know something. We can reward you with some marks for that. That's not a particularly beautiful looking one, but here's 23, which is indeed the mean. 23 take A will be somewhere here. That's probably a bit too far, but that's alright. And 23 plus A is there. The important bit is that we understand it's symmetric about that mean value of 23. And we're told this area is 0.427. So great. How do we do that on the calculator? Go to our calculator. It's distribution, normal distribution. Inverse normal. So we use inverse normal when we know the area and we've got to work out the values. So that's F3. I've already changed it here to central. So the tail is, we don't actually have the tail, we're doing the central value. Oh, you've got to go down the area, 0.427. The mean value, oh, that's the standard deviation. Standard deviation is 5 and the mean value is 23. Go down to there and we execute and we can see the answers there, 20.18 and 25.81. So 20.18 is equal to 23 minus A, or it probably makes sense to do 25.81 is equal to 23 plus A. So therefore 2.81 is equal to A, and 0.81 and 0.18 aren't quite adding up to 100. Ah, there you go, 0.82. Shouldn't have gone with my memory. Should have checked. You, of course, won't have to change tabs. You'll have your calculator in front of you. So that's pretty easy, isn't it? What if you have a calculator where you can't do that, where you can't just push a button and have it say the tail is central? Can I still do this question? And the answer is, of course you can. We're still going to use our calculator, but we're just going to be a little bit more clever about it, because we need to be, really. So here's, again, the area, 0.427. So let's just find, so we're trying to find that one there. Well, we can still do that pretty easily by knowing what that area is. Or if you've got a calculator where you can only do it to the left one, that's probably more common, actually. So let's do this area instead. I'm going to find that one there, and we can still work out A. You could do it from either one. So what's this area going to be? Well, it's going to be 0.5 minus 1/2 of 0.427, isn't it? That 0.427 is symmetric about the mean, so half of it's on the left, half of it's on the right. So on the left-hand side, I have a half. If I subtract that, that's going to tell me what that area is. So that's 0.5 minus 0.2135. I hope I got that right. 427 looks about right. So the area, that's not the actual value. This is still the area. Excuse my incorrectly drawn arrow there. So that's 0.2865 is the area to the left. So now when we go to our calculator, and you've got one here which is, you've got the calculator where you can only do it to the left. Does it matter? Not at all. This is the way I was doing it in Maths A for years with all the kids when they didn't even have calculators and we were looking up tables. So you got it much easier. So here's the area, 0.2865. Mean and standard deviation haven't changed. We execute that, calculate the value, 20.18. There we go. So that value there, 20.18, and that's equal to 23 take A. Bit of magic. A is going to be 2.82. So you can do it either way. Hope that helps. I'll be making some more, so I'll see you soon. Cheers.